Now we'll go for different methods of integration. The first method that you're having is integration by substitution. So we'll take up this one, integration by substitution. The topic that we'll be discussing will be integration by substitution method. Now, what exactly is this integration by substitution? So in the case of the integral, suppose if you have a function, all right, in the denominator or anywhere, I'm just giving you one example over here. One example. Suppose if the function is in the denominator. If you have a function in the denominator and its derivative is there in the numerator over here, then I can use the substitution method over here. This is first case where I can use substitution method like let f of x is equals to t. Then its derivative will come in the numerator and you can integrate it. That is one way of doing it. The second possibility is that suppose if you have a function and along with its derivative you're having times of dx. In this case also, you are going to make the substitution. Let f of x is equals to t. Or even the other possibility is that the function can be in the form of root of f of x and its derivative is there, f dash of x into dx. Even in that case, we are going to take f of x to be equals to t. There are different ways. I've just shown you three ways in which you can make this substitution. What is another form that is possible? You're having integral of f of x whole square into its derivative is there, f dash of x into dx. Now this here, in place of square, you can have cube of 4, power 4, power 5, whatever it is. In general, I'm just putting it as square there. There is another possibility. Or even another possibility that you can get over here is, it is integral of f dash of x by root of f of x into dx. There is another possibility. But now directly I'll take the equation. It is integral of, it is 2x by 1 plus x square into dx. We need to integrate this one. So that's the question we are having, 2x by 1 plus x square. So if you try to observe over here, which form it is. So if you try to observe the denominator, first thing is you have to check whether can you integrate it directly. Is it possible to integrate directly? Do you have any standard formulas for integration, like let the value of 1 plus x squared to be equals to t. We need to differentiate this one. So differentiate with respect to x. So if I try to differentiate this with respect to x, first value 1, the constant derivative will be 0. And the next term that you're having is derivative of x square. So derivative of x square will be what? Derivative of x square will be 2x. So you can just differentiate that one. Derivative of x square will be 2x. And derivative of x is dx, we write, is equals to dt. And you can observe that you are getting the numerator. If you try to differentiate the denominator, you have to get the numerator. And in the numerator, you're having 2x dx. Therefore, 2x dx will be equals to, you can ignore that 0 times of dt. Now put this value back over in the integral. I'll be taking the integral as I. I is equals to integral of this 2x into dx can be replaced by this value dt. So I'll be getting dt divided by this 1 plus x square value which is there. This 1 plus x square value can be replaced by t. So therefore you'll be getting divided by t. So this is nothing but integral of dt by dx. But we know this formula, it is integral of dx by x. Integral of dx by x is nothing but log of x plus the constant of integration c. Or we can even write down this as log of mod x, we write. Because log of the negative value does not exist, or it becomes infinite in nature. Therefore, we'll be taking log of mod. Mod represents log x plus the constant c. But in general, we'll just try to write down log x only. It is understood that whatever values that we are taking over here will be positive only. Assuming that, we'll write down this as log of x only. But if you want to write in terms of mod every time whenever log comes, you can even write in this form also. Both the forms are right. But when you're writing this form, x is always taken as positive. That you have to keep in mind. Integral value will be log of t plus the constant c. But what is the value of t that we have taken over here, substituted? T is 1 plus x square. So substitute that value back there. You will be getting log of 1 plus x square plus the constant c. That will be the required solution.